Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Our topic for today is molecular masses of polymers and some important synthetic polymers. The growth of a polymer chain is linked with availability of monomers and reaction conditions employed. Synthetic polymers have chains of different lengths which may unite with one another, and their molecular mass of one polymer differs from other, so their molecular mass is taken as average of the molecular masses of the different chains. Whereas in natural chains, the chains are of equal lengths and their molecular masses are singular and not average in nature. So accordingly, the average molecular mass can be of two types: number average and weight average molecular mass. So in number average molecular mass, represented as Mn bar for average, it is the average of molecular mass of different type of molecules present in a given sample of polymer. Let the number of molecules having molecular mass M1 be N1. Similarly, molecules having M2 mass, let their number be N2. And molecules having M3 mass, let their number be N3. Then the average molecular mass can be calculated by dividing the total mass of molecules with the total number of molecules. So total mass of N1 molecules will be M1N1. Similarly, total mass of N2 molecules will be M2N2. Multiplication is done. And total mass of N3 molecules having M3 mass will be M3 and total mass of all molecules will be N1 plus N2 plus N3 and so on. So sigma is for total of the product of number and molecular masses, where I is the ith molecular mass and ith number. So the total number of molecules will be sigma Ni, N1 plus N2 plus N3. So average molecular mass will be sigma Ni upon sigma Ni, number of molecules, and this will be called average number average molecular mass. Whereas in mass or weight average molecular mass, represented as MW bar, it may be given as average of molecular masses of groups of molecules with particular masses by their respective molecular mass. Means this number multiplied by the mass will be multiplied by mass again. So total mass of N1 molecules will be N1 M1, and product of these will be this mass multiplied by the molecular mass. So this will be N1 M1 into M1. So M1 into M1 is M1 square. So this becomes N1 M1 square. For particles having molecular mass M2 will be N2 M2 into M2. So sum of products will be N1 M1 square plus N2 M2 square plus N3 M3 square and so on. That is sigma N1 M1 and sigma Ni Mi square. So total mass is this sigma Ni Mi square, and total mass of molecules is sigma Ni Mi. Dividing this with the sigma Ni Mi, dividing sigma Ni Mi square with sigma Ni Mi, we get the mass average molecular mass. The number average molecular mass and mass average molecular mass may be different for the particular polymer. So the term Polydispersity Index is the ratio of weight average molecular mass and number average molecular mass, and it is called Polydispersity Index. If it is 1, then in that case it's called monodisperse polymer. And generally natural polymers are monodisperse because their weight average molecular mass is equal to number average molecular mass, whereas synthetic polymers have some polydispersity index. There, in that case, the weight average is always higher than number average, and so the ratio is greater than 1. The determination of number average is normally done on the basis of colligative properties such as osmotic pressure, elevation in boiling point, and depression in freezing point, whereas the weight average molecular mass is determined with the help of methods like light scattering and ultracentrifuge. Just to take an example how to find out the number average and weight average molecular mass, let's carry out the solution of this problem. A sample of polymer contains 200 molecules of molecular mass 10 raised to power 3 each, 300 molecules of mass 10 raised to power 4 each, and 500 molecules each having 10 raised to power 5 as molecular mass. So calculate number average and weight average molecular mass. To calculate number average, we will multiply the number with the mass. So 200 into 10 raised to power 3. Similarly, 300 into 10 raised to power 4 and 500 into 10 raised to power 5. And then we will add them up. And then we divide with the total number of molecules, 200 plus 300 plus 500. So on solving, we get the answer 53,204 as number average molecular mass. In case of weight average, we multiply the number with the square of the mass. So 10 raised to power 3 was the mass, so we square it and multiply. Similarly, for this mass, number was 300, so 300 into 10 raised to power 4 square and 500 into 10 raised to power 5 square. We add these up and we divide with N1, M1. That is 200 into 10 raised to power 3 plus N2, M2, 300 into 10 raised to power 4 plus M3, N3, N3, M3, 500 into 10 raised to power 5. So on solving, this comes out to be 4,553. So you can see that number average and weight average masses are different. So the polydispersity index will be this term divided by this term is greater than 1. Some commercially important synthetic polymers are either addition or condensation products of the monomers. So in addition polymers, the monomer units usually are olefins, that is, they contain double bonds and their derivatives. The addition takes place under specific conditions, and polymer is normally an exact multiple of monomer. Important members belonging to this class are polyalkenes, polyacrylates, and polyhaloalkanes. Polyalkenes, polythene or polyethylene. For example, polyethylene can be of two types: low density polythene and high density polythene. Low density polythene is prepared by heating pure ethylene to a temperature of 350 to 570 Kelvin under high pressure ranging between 1000 to 2000 atmospheres and in the presence of traces of oxygen 0.03 to 0.1%, or a peroxide which initiates polymerization, that is of free radical nature. So under these conditions, when we polymerize ethene, we get polythene which is containing branches. Because of that, these molecules cannot be packed closely and so density is low. So this kind of polythene is called low density polythene. So low density polythene is chemically inert, tough, somewhat elastic and poor conductor of electricity. Its main uses are for insulating electric wires and in manufacture of flexible pipes, toys, coats, bottles, etc. High density polythene is prepared by polymerization of ethylene at about 333 to 343 Kelvin under lesser pressure, 6 to 7 atmosphere, and in presence of catalysts such as triethyl aluminum and titanium tetrachloride. This mixture is called Ziegler-Natta catalyst, based on the two scientists which were working on these catalysts. So the polymer formed consists of linear chain, so they are closely packed in space. So the density is high, so this polythene is called high density polymer or high density polythene. The high density polythene is quite inert chemically, like low density polythene, but it is tougher, harder and greater tensile strength because of close packing of monomer chains. It is used in the manufacture of containers used for storing chemicals, as it is chemically inert. For manufacture of different houseware items like bucket, dustbins, bottle, pipes, etc., high density polythene is used. Similarly, polypropylene. Propene also contains a double bond, so when this is polymerized with triethyl aluminum dissolved in normal hexane at this temperature and this pressure, 373 Kelvin, 10 atmosphere, the double bond will break and it will get attached from this end and this end. So this unit is repeated again and again to get polypropylene. So polypropylene is harder and tougher than polyethylene and is used for making seat covers, carpet fibers, ropes, etc. It's also used for making wraps for records and packing of textile materials and other articles. Polystyrene is a polymer of styrene and is prepared by heating styrene in presence of benzoyl peroxide, and reaction proceeds by free radical mechanism. So the bond breaks and this unit will get attached again and again in this manner. The polymer so forth is called polystyrene. It is a transparent thermoplastic material and floats over water. It is used for making toys, combs, hot drinking cups, in the manufacture of lining material for refrigerators and TV cabinets, and for making tiles to be used in covering ceilings as well as floors. In the polyacrylates, the monomer units have been derived from acrylic acid. These are also called vinyl polymers because they contain vinyl group in their monomers. For example, polyacrylonitrile. It's also called PAN, polyacrylonitrile, or Odlon. So in this, we have this molecule which is repeated again and again. This bond breaks and it gets attached to another unit from this carbon and this carbon. So this unit is repeated again and again. Polyacrylonitrile or Odlon is the name of the polymer. When we polymerize vinyl cyanide, we get Odlon or PAN, and for this the vinyl cyanide is formed by preparing vinyl cyanide from acetylene and HCN in presence of barium cyanide. So a bond breaks and HCN gets added to get CH2 double bond CHCN. This acts as the monomeric unit to polymerize and form PAN. Properties, it's also called acrylic and is quite hard and fibrous with high melting point. Fibers have good resistance to stains, chemicals, insects and fungi. Acrylic fibers are used in manufacture of synthetic carpets of different types for making blankets, sweaters and bathing suits. Polymethyl methacrylate. So this acrylate group has a methyl group attached as substituent and it's a methyl ester. So this methyl methacrylate in presence of organic peroxide will polymerize to form this bond breaks and it gets attached from here and here with another unit. So this group is repeated again and again to get polymethyl methacrylate, PMMA. It is known by several commercial names like lucite, acrylite, plexiglass and perspex. It is hard and transparent polymer and resistant to effect of light, heat and aging. So it's used in the manufacture of unbreakable lights, protective coatings and dentures. It's also used in making windows for aircrafts. Similarly, if ethyl ester, that is ethyl acrylate, is used as monomer for polyethyl acrylate in presence of organic peroxide, this polymer is formed. It is very tough and somewhat rubber-like in nature and is used for making a variety of cloth and in manufacture of carpets and blankets. Then we also have polyhaloolefins, that is double bonded compounds containing many halogen atoms. For example, Polytetrafluoroethylene. It's also called Teflon. This is Teflon. Monomer is tetrafluoroethylene, and when it's polymerized, it forms tetrafluoroethylene polymer, which is also called Teflon. Tetrafluoroethylene can be obtained from chloroform. So when we react hydrogen fluoride with chloroform, we get monochloro-difluoromethane, which on heating to 1173 Kelvin forms tetrafluoroethylene. This can be polymerized to form Teflon. Teflon is very hard and tough. It is resistant towards heat, acids and bases. It's a bad conductor of electricity and is used for preparing seals and gaskets, which have to withstand high pressure and temperature. Then, to provide insulation for high frequency electric installations, we use Teflon, and for making non-stick surfaces of cooking pans, we use Teflon. Then we also have polymonochloro-trifluoroethylene. So there is one Cl and 3 fluorine in the double bonded ethane. So on polymerization, it forms polymonochloro-trifluoroethylene, PCTFE. Properties of PCTFE are quite similar to that of Teflon. However, it's less resistant to heat and chemicals, and uses are same as that of Teflon. Then polyvinyl chloride. So CH2 double bond CH is vinyl and Cl is attached to it. When we polymerize in presence of dibenzoyl peroxide, we get polyvinyl chloride. Vinyl chloride is obtained by reacting HCl with acetylene in presence of mercury chloride. So we get vinyl chloride. Polyvinyl chloride is a thermoplastic polymer, and its plasticity can be increased by adding a suitable plasticizer like dioctyl phthalate. Phthalic acid is C6H5COOH at ortho position. And when the COOH group reacts with an alcoholic group, the ester linkage, COO linkage is formed. And when it is done with octyl group, where the 3-methyl octyl group forms the ester linkage, and it does it in both the position, we get the plasticizer dioctyl phthalate. This polyvinyl chloride is used in manufacture of PVC pipes for insulating electric installations, for preparing raincoats, tablecloths, handbags, curtain clothes, gramophone records. It's also used for artificial floor covering. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.